Welcome back to the Hyperbolic Coding Chamber. We are quite strapping-tinned for time today, so I think we're going to jump straight into it. Still recovering from jet lag, so we're going to do a classic 26-minute Bangor, and we'll pretty much see where we end up. So I think in the list recently we're just doing. I think recently we're just giving ourselves space to recover. So. First, I felt bad about the shorter sessions, but sometimes it'd be like that. So if we want to be doing this till we die, right, we got to make it palatable. So we're going to do 25 minutes today. Hopefully there are some cool things coming that we will show you soon, but we shall see. But where we are, we're stuck on this problem. So that's what we're going to work on. So we have remove letter to equalize frequency. Remove letter to equalize frequency. You're given a zero-indexed string word consisting of lowercase English letters. You need to select one index and remove the letter at that index from word so that the frequency of every letter present in word is equal. And I think we had some issues recently regarding that. Return true if it is possible to remove one letter so that the frequency of all letters in word are equal. The frequency of a letter X is the number of times it occurs in the string. Frequency of a letter X is the number of times it occurs in the string. So what we initially did was we created letter to occurrences, and then we created a map to map the occurrences to their. I realize now if we wanted the cardinality of occurrences, we could have just used the set. It's unclear why we're counting how many different numbers we have. But the cardinality of it was equal to 1, right? There are some cases where how many of them there actually are does matter. If there's just one, right, you can remove one, right, because it would no longer exist and it would now be it would now be equalized, right? So it has to be more than that. And I think that's what we're checking here. If the first one equals 1 or the second one equals. What are we checking here? Yeah, the code we wrote makes no sense. Must remove exactly one letter and cannot choose to do anything. Basically, let's remove one letter and see if can we remove one letter such that the whole thing is equalized. So we started counting the occurrences of occurrences, which in this case we would have 2 1s and 2. No, we'd have 3. Yeah, we'd have 2 1s and 1 2. Which passes the starting test cases, but it gets quite messy later on. If we have AA and ZZ, we have AA and ZZ. AA and ZZ. That means we still have a cardinality of 1, but we have 2 2s. I think there's a better way to check this. What if we just took the occurrence itself, for example, 2, right? We'll have A has 2, right, and Z has 2. If we take A, we subtract 1 from it, and then iterate through the entirety of the remaining keys with that value, right, we'll be able to know whether or not it's possible to do that. But I think we're trying to cut too many steps here. If we do that, we don't need to do all of this. What we should do instead is do for const key of it's for const key, right, awk of letter to awk. Right, and we're gonna take this key, which is actually, we could just rename it to a letter, right? And we're gonna say new awk would be equal to awk minus 1, right? And there's a case, right, where if we do awk minus 1, when we check, we're gonna take that occurrence for that letter now and iterate through the rest of the possible options for the occurrences. So now we need to either for const letter of word, right? And if we find that a word does not match this, then we'll just keep searching. So we probably need to count matched, and this is going to need to be equal to the length or the size of pretty much each unique letter of the word. We can get that through letter to awk again. Each unique letter of the word. For each unique letter of the word, we need to count how many times the new awk would match the current occurrence. So one way we could do to simplify the code, we can actually just keep track of the old occurrence, right? And then we'll say letter to awk dot set letter to awk minus 1. That way, now when we count the matches, we can set it back to its old awk, right? And then we can say, we're gonna want pretty much what we're doing here. And we're actually not going to care about the letter, but we're going to say if awk equals cur awk, we're going to do count matched plus equal 1. And then we also need to handle the case where awk minus 1 equals 0. If awk minus 1 equals 0, Actually, this doesn't make any sense. Why can't we just check if we subtract 1 from it? Why can't we just check that the cardinality of this set is equal to 1? Cardinality of the occurrences. So we have an example like A 1, right? B equals 1 and C equals 2, right? We would subtract 1 from A, right? We get 0. Now we iterate through the rest of, now we check the cardinality. The cardinality would be 2, 1, and 2. If we were to change C to -1, the cardinality of the set would now be 1, because the number of different occurrences, the cardinality of the occurrences would be 1. And we could add a special case for when we remove them, right? For example, if we had them all like this, then we could remove C like so. Then when we check the cardinality, it would be equal to it would be equal to 1. So this makes sense to me. Does it work for AAZ? We would return false here because we'd always have a cardinality of 2. It would return true for this. Let's check our other examples. BAC, we should return true for this because our cardinality would be 1 once you remove one of them. And then if we check for ACA, we should return true because if we remove one of the A's, then the cardinality should go from 2 to 1. So I think this should work. This way we wouldn't have to do all this iteration stuff. Now we just need a way to get the cardinality based off of the cardinality. Now we just need a way to get the cardinality from a map. We have the occurrences. So we could just say equals and we actually do have to do the stuff we're going to do before, not all of it, but the stuff before we remove the number of occurrences. We're going to say old awk is equal to awk. I'm going to say letter to awk dot set letter to awk minus 1. Right now, if letter to awk dot get letter equals 0, we're going to say letter to awk dot delete letter. After this whole thing is done, if it's equal to 0, we can set it back to what it originally was. Right, and now we're going to say, if we spread the whole thing into an array, right, map it so that we only get the occurrences. Right, and the second value in the array would be the occurrences. Then we can just take the length of that, and that would give us the cardinality. And we'll say if cardinality equals 1, return true. And then at the end, we can return false. Oh, I really thought we had it with this one. Right, and the cardinality does equal. No, actually, no. Yeah, this should return true. If we take C and we remove. I see. Not if it equals 0. Afterwards, in general, if we remove that, we need to add it back. This is taking a long time. So I don't know what happened. Maybe our loop is running forever since we're technically re-adding an item back into the map. If that's the case, I think we just need to and then from here, what we can do, we don't actually have to set it back, since on the next iteration, we'll get a new version of it, which is pretty cool. Okay, now we're getting false. Which is strange. But ABCC, I think we're always no, we're not always evaluating false. Yeah, what's going on here? This passes all the cases. If letter to awk that get letter equals 0, then we add it back in. So I don't understand. This version works. Letter to awk, get letter equals 0. We add it back in. But this actually modifies it. So I don't understand. I'm gonna do console.log. Yeah, I'm not following what's happening. Actually, no, we should add it back because we ran out of output limit exceeded, which we shouldn't have. So let's see why this is running forever. So in this one example, we're running forever. So we have B1, C2, right? After map, we have B, we add it back, right? We add A back. C, A, C, B, A. Or, you know what we could do, instead of deleting it, right? If we do awk -1 and it goes to 0, we'll just keep it like that. This way we never delete it. And then additionally what we'll do is we'll just filter out all zeros. Ah, and I meant to remove this part. So we'll just add 0, we'll just change it to 0. Letter 2. So here we're returning false, which is hard for me to understand. So before map we have ABC. Oh, since I'm filtering out the zeros, I don't think I should have to change this. Oh, I think no, I don't actually see what's happening. Even when they all equal 1, cardinality equals 1. I think what I'm actually trying to do is filter out the zeros, take the size, and then wrap the whole thing in short form. Short form, I want to create a new set from letter to occ, right? And if ocset, right, has 0, then I want to do ocset dot delete 0, and then cardinality will be equal to ocset dot size. So I think this should be it. Well, I think we just have to do what we did before, right? Spread it into an array, right? Map over it, and then just return the occurrence. So now, right, if we have we'll set it back to normal, and I think this should work. There we go. So this problem, yeah, we definitely learned a lot here. I feel like the cardinality of occurrences is something I never questioned before. This should take the linear time over letter to occurrences. We have a finite number of letters. I feel like this should take linear time because we go linear time over the word to create the map, and all we can have are lowercase English letters. All we can have are lowercase English letters. Then the map, which we continually regenerate. The map, which we calculate the cardinality over it's like 26 operations. So yeah. Ocset, we create a new set from the map, which at most can take 26 operations, and this would always be a constant 26 worst case. So I feel pretty good about this algorithm, so I think we'll stop there for today.